Hello, I'm Saïma, the head of AI and computer vision team, and today I'm going to talk about our AI solutions. So you probably know that AI is a performance system that answers a very precisely defined question. So you want to know if there is any cancer in a given image, AI can do that. You want to predict patient relapse, AI can also do that. So AI is a very powerful system that acquires its knowledge and its intelligence from data. Data is very crucial in constructing AI systems. So we basically feed this system with thousands to millions of cases. And it is up to AI to find the rules and to find relevant criteria to make a decision. So at Tribun Health, our data is essentially digital pathology slides. And we are working with a particular type of AI, which is called Convolutional Neural Network, which allows you to capture some patterns from the image and make a decision. And we are essentially using two types of AIs. So we have supervised models and we have unsupervised models. So supervised models requires annotation from pathologists. So it aims to reproduce the pathologist interpretation, reading and annotation. And with this kind of AI, we can do many exciting tasks. So you can classify slides, you can segment tissue and cells, you can detect particular event in the image, for instance, mitosis object. And supervised models is completely different. So it doesn't require any annotation from the pathologist, and it can give you a different interpretation and a new reading. And with this kind of AI, you can generate new images, new biomarkers, or you can also cluster cases. So at Tribun Health, we are employing this technology to make the pathologist's workflow more efficient. So our goal is to save the pathologist's time, to enable his comfort, and also to enable patient to have the best therapy and the personalized therapy. And today I'm going to talk about two examples. So we have first example on colon cancer diagnosis. So it is a tool which allows pre-screening of lesions. So it visualizes a class map indicating the different kind of lesion that could appear in an image. So that's a tool that would save the pathologist's time by guiding his attention toward the risky areas. Our second solution is a prognosis tool for breast cancer. So it will enable pathologists to choose the best therapy for their patient. So traditionally, pathologists analyze a bunch of biomarkers to be able to decide of the therapy. And for example, to know if a patient would benefit of hormonal therapy, it is necessary to prove that at least 10% of cells are reacting to that therapy. So pathologists need to count manually thousands of cells in the image, and that's time-consuming and a hard task. So most of the time they are giving an approximation, but that makes the decision subjective and weakly reproducible. So having a tool that counts every cell in the image is really valuable for the pathologist. So that will ensure reproducibility. The decision is not anymore sensitive to human fatigue or any other condition. It will favor the pathologist's comfort, and it will save the time so that they can focus on more meaningful tasks and more important tasks. So what is particular in our technology? So our algorithms are carefully designed to deliver 4 important criteria to make our solution employable in a clinical workflow. So first, we have a robust system, which is insensitive to stain variation, to scanner variation, which is very common in histopathology slides. Second, we have explainable systems. So our AI is designed to enable pathologists to understand the rationale behind the AI decision. So we enable them to control the system and to improve the system. Third, we have a resilient system which is able to manage out-of-distribution cases, rare events, or improper cases. And finally, we have a responsible AI which respects the patient privacy and in compliance with ethical standards. So another particular thing that we are using in our technology is data-efficient AI, which is very important to have a performance system. So using the data efficiently is really very important to have good performance. So you all know that constructing AI requires a large amount of data. So more you have data, better is your system. But we believe that this is partially true because we all saw that in the previous data challenges that all participants have the same amount of data, they have a lot of data, but different performance. And we won 2 of those challenges because we are implementing data-efficient AI. So we are combining many techniques. So first, we are using data augmentation tools to artificially increase the amount of data by transferring the images from one scanner domain to another scanner domain, for example. We are also working in close collaboration with pathologists. So we are trying to model their knowledge in our AI model. So we are trying to avoid non-reasonable decision by the AI system. And finally, we are using transfer learning method, which allows to transfer the knowledge from one system to another system. So all what we learn today on colon cancer or breast cancer is transferable to new knowledge. And that's really very valuable to have a performance system. So all those technology allows us to have a performance system and have a panel of application including colon cancer and breast cancer, and we are working on additional organs and the new therapeutic areas that will be coming very soon.